Hello, my name is Tyler Ard, and I'm an assistant professor at the USC Mark and Mary Stevens Neuroimaging and Informatics Institute. And today I'm going to be talking about Schol-AR, which is an augmented reality project for scientific communication. But before I get started, I do want to disclose that Scholar is now part of an academic industry agreement with Artist Inc., a startup company, which I do have a financial interest in. And hopefully it'll become apparent why this type of project benefits with an industry agreement as we go forwards, but I do want to disclose that right up front. So to start with, I'm going to be a little different than the other speakers, who I believe are mainly focused on using AR and VR technologies to ask important scientific questions or even develop treatments for particular patient populations. My focus is on data visualization. So I'm interested in AR and VR to be able to see if we can use these technologies to better view, comprehend, and communicate our data. And as a neuroscientist, most of the data I'm going to be talking about today is neuroscientific data. And I'm going to be focusing on the AR applications as well. So before we get into this, we have to know the why. Why do we want to do this? And to do that, we need to understand the current state of scientific communication. And that essentially everything boils down to what can you put in the paper. The paper is the bread and butter of all scientific communication. It's really what gets read the most, what goes out the most, what people are evaluated on, and how scientific communication is done. The standard article and what can go in it. We can have things like supplementary materials or links, but the amount of people that will go to those are a very small reader basis compared to the larger amount that will be exposed to the paper. So really almost all data visualization is focused on what can you put in a paper. And because of that, everything is boiled down to static 2D figures like you see here. This is an example from a colleague of mine, Mike Minkowski, who did a very good job at representing some three-dimensional data in a 2D figure. Uh, but even with this, it's just very limiting. There's a lot of clever techniques about what you can put in a paper, but it's just not as good as what we can do with more modern digital techniques. Here's that same data made into an interactive web page, and this web page is live. You can go to it here if you'd like to. And it's the exact same data from the figure, but it's presented in a way that humans can really understand a lot better. Not only can you understand it better, but there's actually a lot more of it there. When you present data in a figure like the one on the left here, you really have to cut out quite a bit of it. And on the right, we can have it in a much more comprehensible and holistic way. But we can't get that in the paper. We can add a link, which we did in this case, but again, there's just very few people are going to make it here versus what I end up seeing the actual paper that goes out. And that's really what inspired the Scholar project, is trying to see how we can augment normal papers, scientific communication, the backbone of how we communicate, with digital techniques and how we can better represent our data as we move forward, nearly everything is digital except for the communication. And this is really designed to bridge that gap and do a lot better. So the idea is you can just aim your smartphone at a scientific paper and see the attached augmentations to those figures. We can do this with 3D models, like that last example. We could do it with videos, like this example. This is another hippocampus data set. These are neurons inside the hippocampus. And the video example, I think, is particularly interesting because so many fields have tons of data types that they can represent very well in video format that don't fit nearly as well in 2D static figures. So this opens up a whole, broad horizon of types of augmentations that people can use. Um, but it's more than that. We can have more types of data, and as we go on, I'm going to add more and more to this project. Here's a very particular one to neuroimaging or fields that use volumetric data you can see on the right. But overall, I want to try to get across that this isn't just, the cool new way to show data, but it can really have some broad sweeping consequences to science overall. Because, so for example, in this figure, the typical way to report a scientific data set like this in an MRI data set is to have a representative image like this one here. When you do a representative image, you cut out over 95% of the data. You just do one slice on X, Y, and Z and call it good because you can't fit the whole data set in print. To fit this whole thing in print, you would need to print out pages and pages and pages, and it's unrealistic. So because of that, it's just accepted to report this very small subset. versus with augmentation, you can include the entire thing. But that has a lot of implications. So what if the readers are interested in regions that aren't in the subsets? Or what if they don't agree that these are properly representing the overall data set? Or in the worst case scenario, authors could even just leave out slices or areas that don't support their hypotheses and report the representative ones that do. Versus if we can migrate over to using a more holistic type of reporting that not only just shows more, but you can also adjust the values of statistical thresholds and overlays, so we can get away from that stereotypical what's at p of 0.05 is magical type of area. But it can really have some powerful consequences to scientific communication that I'm very excited about. So this presentation comes along with a demo. I believe most of you have this card that got mailed to you with the VR headsets that you have. So if you want to, you can pull this card out and aim your smartphone camera like you're taking a picture at this QR, and that will guide you to download Schol-AR. And then you can view the card itself, or if you don't have the card, you can screenshot this page here and hold it up to the monitor and view it as well. You don't need a printed copy to use Schol-AR. It works on monitors. And then you can, play around with a example 3D augmentation here. And on the reverse side of the card, you can screenshot this as well if you want. But on the reverse side of the card, there's an augmentation that shows a video of various types of data. This is fMRI data. This is 2-photon microscopy. This is some process 2-photon microscopy. And this is a time of flight image of MRI. This one's actually my head. So I like that data set a lot. But there's also, I'll leave this up for a second while I move on. So if you want to screenshot this, you can as well. But there's also a flip side to this project, which is not just viewing it, but I want to make it available for as many people to augment their own content as possible. So that side of the project is now in a closed beta stage, and it's at a web interface, Schol-AR.io. And at this side, you can go and create your project, so your paper or your poster, whatever you'd like to augment. And you can pretty quickly and easily add figures to it. So in this case, we're just going to, in this example, we'll call it figure 1. And then you can upload the target image that you want to augment and the data that you want to augment it with, 3D models or videos or what have you. And then from here, the project actually does everything automatically, and you're essentially done. There's a video on the site that you can view if you'd like to see some more of the nuances to it. But that's all you need, and you'll be given a QR, and your project will be augmented at this stage. So I mentioned this is in closed beta, but everyone here is invited to join it. If you would like to try to augment your own content, you can go to Schol-AR.io and use the beta code SMARTVR in all capitals. If you have any questions, feel free to contact me. And I look forward to seeing you all in the Q&A. Thanks very much.